In this video, I'm going to do a quick overview of decimals and place value. We're going to do a couple of examples where we compare decimals. If you're looking for a review on rounding, you should check out, I did a video specifically on that, since I'm not going to talk about rounding in this video. So let's consider a number. Let's consider the number 324, and we can even say $324, okay? As we move to the right of this number, the value of each digit is worth less. And let me explain what I mean. So the 3 here represents 300. So that really represents $300 since it's in that place. The 2, that's in the tens place, so that represents 20 or 2 tens. The 4 in the ones place represents $4. So when you see a digit, okay, its value is going to differ depending on what place value it's in. And the further right you go, those digits represent, less. And so in this case, we don't have any zeros, but let's consider a number where we did have some zeros. So let's say we had a number like 324.05. So that'd be $324.05. Can we remove this zero? So can I remove this? Is it necessary or could I remove it? Well, anytime we have a zero that is between a non-zero digit and the decimal, it keeps values in place and it has to stay. So that's really important. That must stay. If we eliminated that zero, let's see what would happen. So we'd have 324 point. If we remove that zero, then we just have the 0.5. Well, that's a completely different number. Now we have 324. We'll say this is dollars too. $324 and 0.5 means 50 cents. Now, if I wanted to, I could put a zero at the end, since that's customary when we write money, numbers that represent money. So this zero we say is optional. If it's there, fine. If it's not there, we have the same number, 324 and 50 cents, regardless if that zero is there. So it's really important to kind of be able to tell when the zero is important, when it has to stay, and when it can go. Let's look at example 1. Okay, so identify which of the following decimals are exactly the same value. Put a box around all equal to 0.04 and circle all equal to 0.4. Now, right off the bat, I notice that there are some numbers that have a zero in the beginning. So to the left of the decimal. So like this number, this has a zero, this has a zero, this has a zero, and this one has a zero. And so let's talk about that for a minute. So is that optional or is that necessary? Anytime you have a zero that's to the left of the decimal and there aren't any other digits to the left of it, that part's really important. It is optional. So all of these are optional zeros. And since those are optional, I'm just going to rewrite these numbers without that optional zero. So 0.04, and I'll just write the other ones down too. So I'm copying these numbers down again, only I'm just eliminating that extra zero, that unnecessary zero. Okay, now that I've done that, now let's look at all of these numbers and notice some of these have a zero between the decimal and the digit 4, and some of them don't. Some of them have a zero at the end. And so what I'm going to do is I'm going to first look at the number 0.04 and 0.4. Let's compare those. So remember we said that if the zero is between a decimal and a digit, like it is in this first number, 0.04, this has to stay. This is not optional, okay? So I'm first going to go and I'm going to put a box around all the numbers equal to 0.04. So any number that looks like a 0.04, I'm going to put a box around it. So this one looks like 0.04. This one I'm not sure about. Let's talk about that in a minute. This looks like 0.04, and then this one I'm not sure about. Okay, so let's think about these two, 0.040. If I were to put a zero at the end, does it change the value of this number? It does not. So this is an optional zero. I actually don't even need it. So those would be considered the same number. So 0.040 is the same as 0.04. So I am going to put a box around those as well. Okay. And then next I'm going to circle all that are equal to 0.4. So this one looks like it's 0.4. This one looks like it's 0.4. This next one, let's talk about that in a minute. So we've got some extra zeros on the end of these. So are these the same? 0.40, 0.400, and 0.40. All of those numbers have optional zeros at the end. Because the zeros are just at the end of the number and they're not in between the decimal and a digit, those are all optional. And so those numbers are the exact same as 0.4. So I'm going to put a circle around those as well. Okay, now let's look at example 2. Okay, in example 2, we're going to plot the following decimals in order on the number line below. So the first thing that I notice is that some of these decimals have a negative sign and some don't. And so I'm going to just approach these in 2 separate batches. So I'm going to first look at just the negative numbers. So that would be negative 0.08, and then negative 0.11 and negative 0.2. And remember from the last video, the 0 that's to the left of the decimal, since there isn't a digit to the left of that, it's really unnecessary. So if you want, you can either cross it out, you can leave it if you want, but just know that those zeros don't impact the value of the number at all. And so when I think about those 3 numbers, I'm going to write those down. I'm using the chart up here. So I'm going to write negative 0.08, negative 0.11. I'm choosing to not write down that 0 in front of the negative 0.11, and negative 0.2. And so we can approach this kind of like alphabetizing, where we look at one digit at a time, starting to the right of the decimal. So we look at these digits, and let's figure out which one is closest to 0. So we've got 0 here on the number line, which is right in the middle. Which one of these numbers is closest to 0? So ignoring the negative sign, which one is smallest? Well, since we have the 0 here, that's the smallest number out of the 0, 1, and 2, it means that negative 0.08 is closest to 0, closest to the middle. And the negative 0.2 is going to be farthest from 0. Okay, so that gives us an idea in terms of how these compare. And negative 0.11 is going to be in the middle. And so if we think about starting at 0 on the number line, and then we're jumping to negative 0.10, really we could jump up, we could kind of label, well, what would be in the middle? That would be negative 0.05, and then negative 0.01, negative 0.02, negative 0.03, negative 0.04, negative 0.05, and then 0.06, 7, 8, 9, and then 0.10. And so that allows us to plot negative 0.08, and we can just do that right here. So negative 0.08, okay? Negative 0.11 would be like negative 0.11. That would be 1 tick mark after negative 0.10. And so that's going to go right about here. So negative 0.11. And then negative 0.2 would be down here. We already have negative 0.2 marked, and it's right here. Negative 0.2 is the same thing as negative 0.20, and so that would show up right there. So now let's go ahead and look at the positive numbers. So the positive numbers would be these on the left here, and so we've got 0.19, 0.2, and then 0.02. And so let's do the same thing we did before. We're going to kind of look at these and compare them to each other and see which one would be closest to 0, which one's smallest. So if we look at the first place value, the tens place value after the decimal, the number that's smallest is that 0 here. So it means 0.02, that's closest to 0. It's the smallest number out of these 3. And the number with the 1.19, that's going to be in the middle. And the 2 is the biggest, so 0.2 is going to be the farthest from 0. So I'm going to start by plotting 0.02. And so if I think about where that would be, that's going to be between 0 and 0.10. Think of 0.02 is like 2 tick marks in. So if we made 10 tick marks total, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0.02 is going to be right here. And I could put a 0 in front of that if I wanted to, but I could also leave it out, that first 0. And then the next number is going to be 0.19, which is like 0.19. And so if I've got 0.10 there labeled, 0.19 is going to be almost to 0.20. So it's going to be right here. 0.19, I could put a 0 in front if I wanted to. Now, if you want to, you could just leave it like that. If you want to do show the tick marks, I could. So I could do 1, 2, 3, 4, 5. That would be 0.15, 6, 7, 8, 9. Oh, let me do that one again. So we'll do 1, 2, 3, 4, 5, and then 6, 7, 8. We already labeled 9, and then 10, 0.19. And then our last number is 0.2, and that's already on the number line. It would be right here, 0.20, which is the same thing as 0.2.